All right, so this is going to be the last problem we do together on the randomized block design, and I'm going to use this as a little bit of a summary and review. So we're going to kind of review some of those elements we learned earlier in the chapter as well as draw this diagram. So this one says, can chest pain be relieved by drilling holes in the heart? For more than a decade, surgeons have been using a laser procedure to drill holes in the heart. Many patients report a lasting and dramatic decrease in chest pain symptoms. Is the relief due to the procedure or is it a placebo effect? A group of 298 volunteers, 100 women and 198 men with severe untreatable chest pain were randomly assigned to get the laser or not. The patients were sedated but awake. They could hear the doctors discuss the laser process. Each patient thought that he or she was receiving the treatment, and the laser patients did well. But shockingly, the placebo group showed more improvement in pain relief. Okay, so basically what they did was they took everybody into surgery, they sedated them, so they're kind of a little bit out of it. And so they either talked like they were doing this process or they actually did it. But either way, the patient kind of overheard the same things. And so for that reason, they would assume that they had all gotten that laser treatment. So you're going to discuss the three principles of experimental design: randomize, control, and replicate. Decide if it's not blind, single blind, or double blind. Can we generalize our results to the population, and would we have cause and effect? Explain what the placebo effect is in context and then diagram this experiment. So I know that's kind of a lot of things, but they're all written down in your notes. So go ahead and pause the video. Just do the best you can. If you don't know something, either flip back or when we get to that part of the video, you can just add it to your notes. But this is a good chance for you to get a good little summary review in quick. All right, so let's go through these so you can kind of fill in anything that's missing. So our three principles of experimental design: randomize, control, and replicate. So we don't have a simple random sample. It's stated we had volunteers, but we do have random assignment to treatment. So that's a good thing. The control group. So we do have a control group. That's the group that gets no laser, but because the doctors are talking like they're actually using the laser, they think they are. So that would be our placebo or our placebo group. And then replicate. So this is a large sample size, so that's a really good thing. But if we had to redo this one, it might be a little bit difficult or costly to reduce. This one might be a little bit tricky. You kind of have to have some doctors that are good actors that can fake their way through talking that surgery and things like that. So it might be a little bit tricky, but it is doable to replicate this. All right, so the next question, is it not blind, single blind, or double blind? So we know for sure that it's at least single blind because we do have that placebo group, the group that doesn't get any laser but thinks they do. However, this is an example of one that you wouldn't be able to double blind because the doctors have to be in on it, right? They have to be able to pretend that they're actually using the laser and that they're seeing the things and the results that they're expecting to see when they do this process. So this one is going to be single blind. All right, can we generalize our results to the population? So in order to generalize our results to the population, we need a random sample. Since we have volunteers, we don't have a random sample, so we're not going to be able to generalize these results without a little bit more work behind the scenes here. All right, so do we have cause and effect? And cause and effect would apply as long as those results are statistically significant. And the answer to that is yes. We randomly assign people to treatment groups. So if this is showing an improvement, we would say that we do have cause and effect. Right, and then the placebo effect. So the placebo effect in context of this problem would be patients did not receive the laser treatment, but they still said that their chest pain was better. So that they shouldn't have seen that kind of improvement since they didn't get the laser treatment. And so that's where we're seeing that placebo effect. All right, so let's take a look at this diagram. So we have our 298 people, and I noted that it was not a random sample. We are going to split them into blocks, 100 women and 198 men, and that information was in the problem itself. And again, this one is not randomly assigned to blocks because gender is an innate property of people. So that's not something we can tell people you're this or that. So it is what it is. We have two treatments. Either you get the laser or you don't. So we're going to randomly assign these into groups, into two groups. So the 100 women will be a group of 50 and 50. And the 198 men will be a group of 99 men and 99 women. Okay, so there's our random assign. And then each of those, the group of women, one will get the laser, one will not. And the men, same deal. One will get the laser and one gets the placebo. Right, we'll compare the pain relief that people report for the women and for the men. And then we're going to see if there's an overall comparison here. So maybe more men felt like the placebo helped them than the women, or maybe an equal amount of men and women thought that the placebo had helped them. So again, we'll do that comparison at the end. All right, so hopefully this was a good, just kind of little summary of what we've done in chapter 9 so far. And then come back in the next video, we're going to look at matched pairs, which is the last experimental design we're going to look at in this chapter. Actually, in the course, we're only doing those 3 experimental designs. So